Hi. Okay, so science o'clock. We're basically the last proper lesson of this chemistry topic. So in the previous lesson, you learned about the reactivity series, how the reactivity series is created, how it is put together from information from experiments. So you react different metals with different substances. You put them with water, you put them with acid, you react them by burning them in air, oxygen, and you see which ones react more than others, and then you rank them, and therefore you have a reactivity series. Now, if we were in school, we would be doing an experiment to test this, but we are not in school. We are locked down at home. You can't do these things at home. You may have some of these things at home, but you can't do the full series. So unfortunately, we're going to do a digital version where we'll look at videos on YouTube of some people that have done it, and we'll take the information and then we'll answer some questions on that, and that will bring this kind of chemistry topic to a close. Very short topic. Okay, so the aim is to be able to test the reactivity series, and we're going to start off with a few questions. First, can you just give me, so you'll need a periodic table, look at your periodic table, can you give me 5 metals that have a low reactivity, 4 metals that react with water, 3 metals that have a high boiling point, 2 non-metals that are solid at room temperature, and 1 metal less reactive than calcium but more than aluminium. So in a second you're going to pause, you're going to write down the answers, and then when you've done that, unpause and I'll go through those with you. Okay, go. Done? Excellent. See if I can get the pen working today. So 5 metals that have a low reactivity. So anything from the bottom rung. Gold is 1, silver is another, copper is another low one, zinc and iron, all relatively low on the reactivity series. Next one, metals that react with water. You can just basically look at the other end of the reactivity series. That would help you. The simplest ones is perhaps to start with the alkali metals. We've got lithium, sodium, potassium, we could even say cesium. Metals that have a high boiling point. Basically, that's all metals, apart from one, which is mercury. So any metal, so iron, aluminium, copper, zinc, they all have a pretty high boiling point. Next one, 2 non-metals that are solid at room temperature. On your periodic table, if you look at your periodic table, if you look at the right-hand side, that's where the non-metals are. Now, if you're using the one that's in your planner at school, the symbols are color-coded, and there's a different color for solid, liquid, and gas, so you can use that. But you can perhaps use your own brain, I suppose, for things that are solid. So if we look back to a couple of lessons that we've had, group 7 is halogens. Excuse me, halogens are non-metals, we know that. What's the solid non-metal halogen? Iodine is non-metal. And another one, nice and simple, carbon is a non-metal. Sorry, the cat's being very loud. And 1 metal less reactive than calcium, but more than aluminium. So if you look at your reactivity series, most reactive at the top, less reactive at the bottom. What's an element between calcium and aluminium? Magnesium is a good example. Excuse me. So we've done the starter. Time to move on. The first thing you need to do is copy this down. Copy this down in your book, because we're going to fill this in. There are different ways to fill it in, but to do that, this is basically the main piece of work for today's lesson. So we're going to see what would happen if you mixed calcium with cold water, warm water, hydrochloric acid. Copper with also cold water, warm water, hydrochloric acid. Magnesium with cold water, warm water, hydrochloric acid. And then zinc, the same, cold, warm, and then hydrochloric acid. So pause the video, copy down the table into your book, and then when you're done, unpause. Okay? Good. Now, there are different ways to do this. You could probably just do this without watching any videos. From your last lesson, you should have written down the reactivity series in your book. It was They gave you the mnemonic to remember it. Please send Charlie's monkeys and zebras in cages. Something, yeah. You could do that. In fact, I've got it here. There we go. Please send Charlie's monkeys and zebras in lead cages securely guarded. So, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, silver, gold. Okay, check. So the ones we're talking about are copper, zinc, magnesium, and calcium. Okay, so copper is at the bottom of our reactivity. So copper is going to do the least. Then there's zinc. Zinc is the next one up in of the four that we've chosen for our table. So that will react more than copper, but less than magnesium. Magnesium is near the top, but calcium is above that. So calcium is going to be more reactive than magnesium is going to be the most reactive of all. So we can just work that out. So, for example, if we know that zinc has no reaction with water and zinc's more reactive than copper, we can fill that one in straight away. Copper has no reaction with cold water. No reaction. Like that. If it has no reaction with cold water, and it also has no reaction with hydrochloric acid, with warm water, it's also going to be no reaction. And then we notice these ones. The most vigorous reaction is going to be with hydrochloric acid. The least is with cold water. So whatever happens to this hydrochloric acid, it goes down in reactivity. Then the easiest way to do is to watch these two videos. I'll add the links in the VLE thing. So watch these two. Someone else who is a proper chemist has done these either at school or at home, hopefully not at home. He's done one with water and they've added an indicator. So sometimes you can see if there's a reaction, and another time he's done it with acid and you just look for the bubbles. Okay? So watch those videos, look at your reactivity series, and then try and fill in the table. Go. Oh, not too far. Okay, now you've watched the videos, hopefully you can fill in your table, and it should look something like this. So you notice for calcium, we had already filled in the last column. It was very vigorous fizzing. You put it with acid, it fizzes very, 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 very violently, and the calcium disappears, almost dissolves very quickly. So if you add warm water, it's going to be less of a reaction, a slower reaction. So there is vigorous fizzing, just not very vigorous fizzing, and the calcium dissolves, but maybe not very quickly. If you do it with cold water, it's a gentle fizzing. The calcium slowly dissolves. We filled in the copper, no reaction for everything. If we compare magnesium and zinc, because zinc's less reactive, it doesn't do any reaction with water at all. So for cold water, no reaction. For warm water, no reaction. For hydrochloric acid, it does fizz, slowly fizzes, and then it dissolves. For magnesium, you put it with acid, it does fizz quite vigorously, quickly dissolves, and it will react if you put it with just water. Some bubbles, but the reaction is quite slow. Using this, we're able to work out our order of reactivity. It's what we would have done in school. So because calcium reacts with everything, it goes as number one. Magnesium reacts with acid and warm water, so it goes number two. Zinc only reacts with the acid, so it appears in number three. And copper doesn't react at all. If we were to add different metals in, you could probably work out the reaction for those. Say, for example, if we added in gold, what would you expect? Yes, you get no reaction from all of these. What about aluminium? Aluminium should be above zinc. So there we go. So you have all of this. Now it's time to answer some questions based upon this. I've just done that. So use your observation to work out the order of reactivity of the four metals and describe how you judge them. So you don't have to worry. Okay. Explain. So these are the questions you're going to need to answer in your book. So write them down in the book and don't forget to send a photo to your teacher via email at the end. Explain why it's not possible to deduce an order of reactivity when these metals are added to cold water. Look at the column that says cold water. Why is it not useful or easy for you to deduce the reactivity? When these things are placed in the water or whatever, they produce a gas. What is the name of the gas it produces when it reacts with water? Then, how would you know it's that gas? What is the test for the gas produced when calcium reacts with water? So if you have that reaction going, what's the name of the gas? And how would you test it? How would you prove that was the gas? Write those answers down. Pause. Right, let's carry on. Okay, so you've watched those videos, you've seen the reaction. Calcium is pretty vigorous. Water, this is very violent. Acid, this is really violently. But what's the word equation for calcium with water? Hint, the first two parts are there. Calcium with water. Calcium plus water. Splendid. And then what does it turn into? If you're not sure, you can use the question below to help you out. Because it then's asking about the balanced equation. Well, there's calcium. Here we go. Here's calcium. There's water. What does it turn into? CaOH. There we go. You can use that to answer number 4. And then when you come to number 5, it's also missing something at the end. But there's a clue because it tells you, it's the state symbol, tells you it's a gas. So you have to work out what a gas. And what gas is always produced when those metals react? That's number 5. There's 2 number 5s. I'm sorry. Okay, next one. Write a word equation for magnesium with hydrochloric acid. So, magnesium plus hydrochloric acid. Arrow. What does it turn into? Something, 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 something. Again, if you're not sure, you can look at the question below to help you turn that into words. And then the question below, number 7, says complete and balance the equation. A bit trickier, so you can use the information from the part above, but make sure, for example, we've got 1 magnesium here, 1 magnesium here, that's good. But notice, 1 chlorine, 2 chlorine. So it's not quite. And also, we've got a H here, but there's no H's on this side. So use the information to answer the questions. Complete the following sentences. Don't write out the whole thing. Try number 8 and write out the 2 missing words. Okay? You can do that. Just the missing words. Don't write the whole thing out. There's no point. But read it. And at the end, we didn't do this and you didn't see this. You might be able to watch this on YouTube, but you've watched the reaction with hydrochloric acid. The reaction with hydrochloric acid for magnesium is pretty vigorous and it produced a gas. Gas was hydrogen. How do we test that? Squeaky pop. Maybe that's useful later. But the acid they did was hydrochloric acid. Now we switch it to sulfuric acid. What differences would there be? Can you remember the formula for sulfuric acid? Maybe if I give you a H2SO4, there's a 2. It's a sulfuric acid. Okay, so can you write the word equation? Magnesium plus sulfuric acid, arrow, something, something. Then can you turn it into a balanced equation? And then the last thing, what would it look like? If you put the magnesium and acid, what would you see? If you did it in a boiling tube, what would you see when you mix those two together? Okay, lots of questions? Totally doable. Okay? Good luck. Love you. Bye.